Welcome back! I'm Muammar Lone, and in our previous episodes, we explored the world of natural language processing and dove deep into linguistic concepts. Today, we're rolling up our sleeves and getting practical. We're going to learn how machines actually process and understand text. Imagine you're teaching a child to read. First, they learn individual letters, then words, then sentences. Teaching machines to understand language follows a similar path, but with some fascinating twists. Today, we're going to uncover the fundamental techniques that transform raw text into something computers can actually work with. Let's start with a seemingly simple task. Take this tweet. OMG, this is amazing! Can't wait to try it! Excited. How would you help a computer understand this? It's filled with challenges. Multiple exclamation marks, unconventional capitalization, abbreviations and numbers as words, emojis, hashtags. By the end of this episode, you'll understand exactly how we tackle these challenges and many more. The text processing pipeline. Text processing is like a conveyor belt in a factory, with each station performing a specific task. Let's walk through each station and understand what happens there. First station, text extraction. Think about all the different places text can come from. Web pages with HTML tags, PDFs with formatting, images with embedded text, social media with special characters, email threads with headers and signatures. Each source presents unique challenges. For example, when processing a web page, we need to remove HTML tags, extract meaningful text, preserve important formatting, handle special characters, maintain document structure. Let's look at a real example. Here's a snippet of HTML. Welcome to our site. Check out our amazing products. The raw text we want is, welcome to our site. Check out our amazing products. But it's not always this simple. Consider this email. From john@email.com to sarah@email.com. Subject, meeting tomorrow. Previous message. Let's meet at 2 p.m. Best regards, John Company logo. We need to identify and extract just the relevant content. Tokenization, breaking text into pieces. Now we reach one of the most crucial steps in text processing, tokenization. This is where we break text into meaningful pieces or tokens. Seems simple, right? Just split on spaces? Well, let's look at some challenges. Contractions. Can't, can plus not, we're, we plus are, won't, will plus not. Compound words. Fireplace. One word or two. High quality. How do we handle hyphens? New York City. 3 tokens or 1? Special cases. Dates. 2024-01-05. Times 3:45 p.m. URLs. https www.example.com. Email addresses. user@domain.com. Phone numbers. 555-123-4567. Let's try tokenizing this sentence. Mr. Smith's wallet was stolen at 3:45 p.m. on January 5th, 2024. He lost $500. Proper tokenization needs to handle abbreviations, Mr. Process possessives, Smiths. Maintain time formats, 3:45 p.m. Handle dates, January 5th, 2024. Process currency, $500. Deal with punctuation marks. Text normalization, creating consistency. After tokenization, we need to normalize our text, making it consistent and clean. This is like standardizing ingredients before cooking. Let's look at the main normalization steps. Case normalization. Hello. Hello. Text. Text. NASA. NASA. But should we? Special character handling. Remove or replace accents. Cafe. Cafe. Handle emoji. Thumbs up. Process symbols. C. C. Number standardization. Third. Third. 2. 2. 1,000,000. 1,000,000. Text cleaning. Remove extra spaces. Handle inconsistent punctuation. Standardize quotation marks. Remove control characters. Deal with encoding issues. Consider these equivalent expressions. iPhone. 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 Phone. For a search engine to work effectively, these need to be normalized to a standard form. Stemming and lemmatization. Now we come to two powerful techniques for reducing words to their base or root form: stemming and lemmatization. Stemming is like rough chopping. Running, run. Fishes, fish. Better, bet. Oops. Lemmatization is more precise. Running, run. Better. Good. Was. Be. Let's compare these approaches. Stemming examples. Historically. Histor. Friendship. Friend. Argued. Argue. Beautiful. Beauty. Lemmatization. Examples. Historically. Historical. Friendship. Friend. Argued. Argue. Beautiful. Beautiful. Each approach has its trade-offs. Stemming is faster but less accurate. Lemmatization is slower but more precise. Stemming can create non-words. Lemmatization requires dictionary lookup. Stop word removal and frequency analysis. Next, we tackle stop words. Common words that often don't carry much meaning. Articles, a and the. Prepositions, in, on, at. Conjunctions, and, but, or, but be careful. Sometimes stop words are crucial. To be or not to be. The who. Let it be. After cleaning our text, we can analyze word frequencies. Most common words, rare terms, n-gram patterns, keyword density, topic indicators. Let's analyze this paragraph. The quick brown fox jumps over the lazy dog. The dog sleeps while the fox runs away. After processing, 1. Remove stop words. 2. Lemmatize. 3. Count frequencies. 4. Analyze patterns. Advanced processing techniques. Now let's explore some more sophisticated processing methods. Named entity recognition, NER. Finding names, John Smith. Identifying locations, New York. Detecting organizations, Microsoft. Recognizing dates, next Tuesday. Spotting monetary values, $500, part of speech tagging. Nouns, cat, freedom. Verbs, run, think. Adjectives, happy, green. Adverbs, quickly, well. Pronouns, he, they. Dependency, parsing. Subject-verb relationships. Object identification. Modifier attachment. Phrase structure. Grammatical roles. Sentiment analysis. Positive-negative tone. Emotion detection. Sarcasm recognition. Opinion mining. Intensity measurement. Real-world applications. Let's see how these processing techniques enable real applications. Search engines, query understanding, document matching, relevance ranking, suggestion generation, result highlighting, content analysis, topic extraction, summary generation, keyword identification, category assignment, trend analysis, social media monitoring, sentiment tracking, trend detection, influence measurement, crisis identification, engagement analysis, customer service, query classification, response generation, priority assessment, routing optimization, feedback analysis. Common challenges and solutions. Text processing isn't without its challenges. Let's explore common problems and their solutions. Language variations, regional differences, informal language, technical jargon, slang and idioms, code switching, ambiguity. word sense disambiguation, contextual meaning, pronoun resolution, sentence boundaries, phrase attachment, noise handling, spelling errors, typos, OCR mistakes, mixed languages, random characters, performance optimization, processing speed, memory usage, scalability, accuracy balance, resource management, future trends. The field of text processing is constantly evolving. Here are some exciting developments. Multilingual processing, cross-language understanding, universal tokenization, script normalization, cultural adaptation, language detection, real-time processing, stream processing, incremental updates, dynamic adaptation, live analytics, instant feedback, multimodal integration, text-image processing, speech, text conversion, video captioning, document understanding, mixed media analysis, privacy, preserving processing, data anonymization, secure processing, privacy guarantees, compliance handling, ethical considerations, practical implementation. Let's look at how to implement these concepts. Basic pipeline. 1. Text extraction. 2. Tokenization. 3. Normalization. 4. Stop word removal. 5. Stemming lemmatization. 6. Feature extraction advanced pipeline. 1. Language detection. 2. Entity recognition. 3. Sentiment analysis. 4. Topic modeling. 5. Relationship extraction. 6. Summary generation. Best practices. Input validation. Error handling. Performance monitoring. Quality assurance. Documentation testing strategies. Closing. As we wrap up our exploration of text processing fundamentals, remember, clean data is crucial. Context matters. Balance, accuracy, and speed. Consider your use case. Test thoroughly. In our next episode, we'll dive into how we can use this processed text to train machine learning models. Until then, try this exercise. Take a paragraph from your favorite book and 1. Identify the pre-processing steps needed. 2. Think about potential challenges. 3. Consider different applications. 4. Experiment with different approaches. I'm Muammar Lone, and thank you for joining me in this practical exploration of text processing. Remember, every piece of text contains hidden patterns waiting to be discovered. Keep exploring, keep processing, and I'll see you next time. Stay curious and keep pre-processing.